is now starting. All attendees are in listen-only mode.
Hi everyone, and welcome to the AEE member webinar today. We will, as always, go through a few little logistics first, and then I will introduce you to your speaker and your topic for the day. So first of all, we thank you for joining us. Understand that, as always, we will follow up in the next 24 to 48 hours with an email that will contain a link to the recording of today's webinar, plus a link to your certificate of attendance. During the course of the webinar, if you have questions for our presenter, Ms. Yeganar, today, we can post those, please, in the questions section of your control panel. You also have a chat section in there. Please keep the two separate. Keep the questions for our presenter in the question section, and any queries that you may have for me, please post those in the chat. And I'm sorry I didn't introduce myself. I am Sharon Hewson here at AEE, so please feel free to post any questions for me in that chat section. We will be handling Q&A at different times throughout the presentation. Our presenter will pause at appropriate moments to allow you guys to post your questions and answer those before we move on with the presentation. With regards to copies of the presentation, I will put this in the follow-up email, but please reach out to our presenter with any technical questions regarding the content and to request copies of the presentation. So once again, thank you all for tuning in today, and I'm going to go ahead and introduce today's speaker. We have Ms. Kimia Yeganar, who is joining us today to present to you an overview of measurement and verification in C&I electricity conservation projects. Kimia is the engineering manager at Clear Result, currently working out of Toronto, Canada. She is working on the Save on Energy retrofit program administered by the Independent Electricity System Operator, which is also known as IESO. She has previously worked as an energy specialist on the Process and Systems Upgrades, the PSU program, for industrial, large and commercial customers in Ontario for the three previous years. As an energy specialist, Kimia's work has involved the review of studies and projects that were eligible for program incentives and developed IPMVP compliant MMD plans. Kimia is a professional engineer. She's also a CEM and a CMVP, so has been heavily involved in AEE over the years, and we thank you for that, Kimia. And without further ado, I am going to pass control over to you.
Thanks, Sharon, for the introductions. Can you hear me fine?
Yes, I can hear you perfect.
Perfect. Thank you. Good afternoon, everybody. Thanks for tuning in today. I'm very excited to be doing a webinar for the AEE. Next slide. There we go. I would like to start off by giving special thanks to the IESO, the Independent Electricity System Operator, for allowing us to use program data for this paper. I would like to thank my co-author on the paper, Kadra Branker, and I would of course like to thank my colleagues and managers at Clear Result for their continuous support on papers. Today, I'm going to start off by telling you a little bit about where I work and what I do. I will provide an overview of measurement and verification with some MMV fundamentals. I will tie it into Ontario's conservation demand management by showing some insights from the PSU program. Lastly, we will end with some key takeaways and end with a Q&A session. As Sharon mentioned, feel free to type your questions in the chat box. If you still have unanswered questions at the end of the presentation, or you want to chat about anything that was mentioned, feel free to get in touch with me. I first presented this topic at the AEE East Conference, which took place in March 2019 in Boston. Shout out to the AEE for having me as a presenter. Today, I'll be presenting a slightly modified version of what I presented back in March. As Sharon mentioned, I work for Clear Result in downtown Toronto. Clairsalt is a provider of energy efficiency services, running more than 700 programs across North America and employing more than 2,500 people across 70 offices. We have 110 employees in Canada. At our Toronto location, we work with the independent electricity system operator on the programs under the umbrella of Save on Energy programs in Ontario. These programs include the Retrofit Program, the Energy Manager Program, the Energy Performance Program, EPP, and the Process and Systems Upgrade Program, also known as the PSU program. This paper is related to the PSU program and utilizes data from the program. The PSU program is geared towards complex, large commercial and industrial upgrades. As the delivery partner for the IESO for the PSU program, we conduct technical review of applications, we develop measurement and verification plans, and conduct measurement and verification reporting, as well as program support and operations support. We all know about the importance of measurements in science and engineering. Measurements are the most important aspect of performance engineering, as Grace Hopper, a pioneering computer scientist and United States Navy admiral, once said, "One accurate measurement is worth 1,000 expert opinions." Conservation demand management has played a very important role in the diverse C&I sector in Ontario, not to only reduce electrical load on the grid and avoid costly new infrastructure, but to also significantly cut costs for the participants. Consequently, more efficient operation and reduced downtime are only some of the inherent benefits to the participants. As industrial conservation measures have matured in Ontario, MMV has become more important than ever. With successful completion of some of the simpler ECMs, a lot of industrial facilities are looking at more complex energy conservation measures where costly meters and complex calculations could be involved. MMV plays a very important role as it provides an effective means of verifying the realization of contracted savings. It ensures value for ratepayers and other stakeholders. It helps identify gaps, opportunities, and challenges specific to various sectors, and it ensures continuous improvement in these programs. We use the IPMVP, the International Performance Measurement and Verification, as our guiding document to develop measurement and verification plans. In order to follow energy efficiency best practices, MMV must be well integrated into the process of identifying, planning, installing, and maintaining ECMs. There are guidelines for MMV, but not standards, because each non-prescriptive measure is unique and really it cannot be generalized. Savings are calculated by comparing the facility's baseline energy and the reporting period energy while considering any routine and non-routine baseline adjustments based on conditions of the reporting period. Routine adjustments are those that are a result of changes in process-independent variables. An independent variable could be CDD, HDD, flow rate, hours of operation, etc., depending on the project. Non-routine baseline adjustments are those that are a result of unexpected changes in the static factors of the facility. This could be a major change in product, process, or a change in facility size, for example. Savings can only be calculated, not measured, as they represent the avoided energy consumption as a result of implementation of the ECM. For a project to be IPMVP adherent, both the baseline energy and the reporting period energy have to be measured. IPMVP provides 4 options for establishing an MMV process. MMV plans must specify the chosen approach and define the measurement boundary accordingly. Option A and option B are used if the system can be isolated from the rest of the facility. Option A involves measuring key parameters while stipulating others. For example, a lighting project where the baseline energy, where power draw of baseline period and reporting period lights are measured on a short-term temporary basis and hours are assumed, would go under option A. Option C, whole facility, involves the use of existing utility meters or whole facility meters to evaluate the energy consumption before the implementation of the ECM and after the implementation of this ECM. As utility bills are based on utility meter measurements, billing values can typically be used to analyze the baseline energy and the reporting period energy. Option C is best when there are multiple ECMs at a facility where it could be very challenging to isolate the ECMs. It should be noted that for option C, the savings must be large compared to the unexpected variations in the baseline. Option C is rarely used in industrial projects due to the difficulty of detecting the actual savings. Option D, calibrated simulation, lastly, includes the use of a simulation software to model the energy performance of the entire facility. The simulation model must be calibrated using facility monthly billing data or other metering available. Option D is typically used for high performance new construction projects. In choosing the appropriate MMV option, it's important not to take a prescriptive approach as each project is unique. It is important to evaluate the cost versus degree of accuracy trade-off. The cost of MMV should be justifiable based on the project value, and it should not be too burdensome for the participant. Uncertainty analysis is also an integral part of MMV, and MMV reports must be as accurate as possible based on the incentive value. Where accuracy has to be compromised for cost, it is important that the CMVP applies additional conservatism in the analysis. In addition to IPMVP, there are some other MMV frameworks that are worth mentioning. One is ASHRAE Guideline 14, and one is FEMP, Federal Energy Management Program. ASHRAE Guideline 14 is the most technical out of the 3, and it includes examples on specific systems such as pumps, chillers, etc. It also includes specific sections on physical measurements and types of metering. The Federal Energy Management Program, established by the DOE, provides detailed guidelines that are specific to ECMs under performance contracts in the federal sector in the US. As guidelines are general, they often do not cover unique situations and challenges that arise when dealing with real-world projects. Some of these challenges experienced include changes in static factors or non-routine adjustments, as they're called, interacting projects, missing data, inaccurate data, or unexpected shutdown. Inaccurate data could be due to a faulty meter or due to malfunctioning equipment. Low detectability of savings due to a very high uncertainty in savings, which could be a result of the savings being a very small percentage of the baseline energy. Hypothetical baselines in cases of new construction, high performance new construction projects. And lastly, cost versus accuracy of metering for complex yet small projects. On this slide, you can see two sample measurement boundary diagrams for CHP systems. The combined heat and power program was discontinued as of July 2018. However, we did see a lot of these projects. We did see a lot of these projects go into service as well. On the left side, you can see a sample measurement boundary diagram for a CHP system consisting of an internal combustion engine. You can see the power meters, the natural gas flow meter, as well as the energy meter, which is used to calculate the total system efficiency of the system. On the right side, you also see a CHP system. This one consists of a GTG, a gas turbine generator, a duct burner, and a heat recovery steam generator. Please note that the PSU program underwent a policy change as of March 2019, as a part of which the interim framework was introduced, along with a new set of program rules. As this paper and the corresponding presentation was finalized in February 2019, it does not cover the interim framework. The data in this paper reference the program as it was prior to the change under the Conservation First framework called CFF. CFF started back in 2015. In April 2018, however, a redesign of the CFF program rules took place based on evaluation, measurement, verification data, and feedback from stakeholders in order to increase participation in the program, enhance cost effectiveness and conversion of studies to projects, as well as increase customer satisfaction. From here on, wherever I mention old rules, I'm referring to the CFF program rules prior to the redesign of April 2018. And wherever I mention new rules, I'm referring to CFF program rules after the redesign of April 2018. I'm now going to go through some of the most important changes that took place as a part of redesign of the CFF program rules, which are related to measurement and verification in the program. Change number one is restructuring of the program incentive. Under the old rules, the program paid for 100% of the approved incentive amount when a minimum of 80% of the anticipated electricity savings were achieved. Under the new rules, incentive was paid based on actual savings up to 120% of the approved amount. The payment restructuring to a pay-for-performance structure put more focus on accurate MMV and appropriate baseline adjustments. The second change was changes to MMV reporting periods. Under the old rules, projects with an incentive of greater than $1 million had a reporting period of 10 years, which was considered quite long by some participants. Under the new rules after April 2018, the MMV reporting period was changed to 1 year for all sizes of projects, regardless of incentive size, unless extended by the IESO. Regardless of the shorter MMV reporting period, to ensure cost effectiveness and value to the ratepayer, a right to audit clause was added, along with minimum record keeping requirements. As part of the changes for the interim framework, the MMV reporting period for large projects was increased to 5 years. Another important change with regards to measurement and verification was changes to thermal metering requirements for combined heat and power systems. Under the old rules, thermal metering was only required for projects with incentives greater than $200,000. However, under new rules, thermal metering was required for all CHP projects regardless of size and incentive amount. Under the old rules, 65% total system efficiency had to be achieved for compliance. Failure to meet 65% meant incompliance. However, under the new rules, if TSE was between 57% to 65%, the incentive would be discounted. There were other changes as part of the redesign of the program, which I'm not going to cover here, as they're not directly related to measurement and verification of the system. Based on more than 6 years of MMV reporting period data for the IESO's PSU incentive program in Ontario, interesting data can be observed. The MMV data here shows that ECMs are being implemented at a variety of facilities across various industries. Large savings are observed in the food and beverages, manufacturing, and automotive sectors. The savings comprise of contracted savings values for projects that are either currently under MMV or have finished their MMV reporting period. It is also interesting to look at the technology makeup of these ECMs. Behind the meter generation projects or BMG projects, which include natural gas fueled CHP and waste energy recovery, make up most of the savings. In Ontario, the CHP program was very well received across a wide range of industries, from multi-residential and government, such as hospitals and universities, to manufacturing and automotive facilities. These CHP projects sometimes involved large systems with multiple IC units or gas turbine generators, sometimes even coupled with absorption chillers, which added to the savings, thus resulting in much higher savings compared to energy efficiency projects. Some typical energy efficiency projects include compressed air system upgrades, refrigeration optimization, installation of VFDs, motor replacements, so on and so forth. The realization rate is the ratio of energy savings verified through MMV over total value of contracted savings. The realization rates across the largest 10 sectors are shown here. High realization rates across various industries and projects show good MMV practices, including but not limited to accurate baseline equations and appropriate adjustments. In this histogram, you can see a breakdown of percentage of total in-service projects by number, which fall under a certain range of realization rates. Based on the analysis, as you can see here, over 55% of all in-service projects have a realization rate of between 90% to 150%, which further supports the PSU program changes that allow for pay-for-performance structure up to 120% of the anticipated savings amount. It appears that previously, when the program was not pay-for-performance based, there was some inherent conservatism used by some participants concerned about meeting the contracted savings target. Lastly, a few points to take home. MMV provides an effective means of evaluating projects in order to ensure value to ratepayers in ratepayer-funded incentive programs. MMV data provide verifiable results that can be used to continuously improve incentive programs for all stakeholders. MMV of each non-prescriptive project is unique. It cannot be generalized, and a thorough understanding of the system of interest and the project is essential for development of the MMV plan. Program data, over 6 years of program data showed high realization rates across various sectors, which reflect accurate MMV. In addition, they showed the presence of a multitude of sectors in energy efficiency in Ontario. With that, I would like to move on to any questions that you might have. Thank you for your attention. It was a pleasure presenting today. Please feel free to get in touch with me if you have any questions or you would like to chat about anything that was covered today. I'm just going to open.
Thank you, Camille. We do have a couple of questions in here, and I'm sure everybody listening in, if you have other questions, go ahead and post them in the question section. The first one that we have in here is, how do you account for variability in production rates during MMV process?
Sure, I can take that. Could you expand on what you mean by, do you mean as an independent variable, using production rate as an independent variable? So, okay, maybe
it doesn't
let me give a,
yes,
okay.
The answer was yes.
Okay, yes. So the baseline adjustment typically does not use production. In some cases, we have seen baseline adjustment equations that use production. It is a difficult independent variable to have. I would say just because it is not always available and it cannot always be shared. Sometimes there's confidentiality concerns. Yeah, that limits use of production data as an independent variable in the baseline adjustment equation. Does that answer your question? Just pop out the question window.
Someone was asking to go back to one of your slides to clarify.
Sure, Sharon, I'm just trying to pop out the question window. How do I do that again?
Click on where it says questions, the actual bar that says questions, the gray bar, and just drag it.
Oh yeah, okay. It is very small. I can't see the questions right now. There we go.
So we're on the third one down right now. The first one was just a good morning. Then you answered that question.
Okay, I got it.
And then there was a follow-up actually to that where you said, did that answer your question? The same member has come back and said, can regression modeling be used to address production variability?
Yes, if production data is available and can be used as an independent variable, yeah, definitely.
Okay, can you see the questions? Okay.
No,
let me see.
Huh.
We got a few more coming in now. I can read the next one to you.
Okay, let me see. Oh, there we go.
So one's asking about the slide showing the 90 to 150 before the conclusion slide. Just clarifying what that was about. So
sure. Okay, there we go. Okay, now I can see the questions. slide. Okay, this one. I'm going to go back to that slide. This one, I believe. Sorry, what's the question again?
Just says, what was the slide showing the 90 to 150 before the conclusion slide about?
Oh, yes, there we go. So this histogram shows the percentage of in-service projects by number based on their range of realization rates. 55% of all projects would fall between 90% to 150% realization rate. Does that answer your question?
Okay, we'll move along and then
Yes.
that will pop up
Okay.
again if it didn't. So,
sure. So the next question is, can you mention any non-routine adjustments used?
No, go way up in the list. That one was much further down. If you go way up, we were looking at...
Even the extended window is quite small.
Yeah.
Oh, okay, there we go.
I just
What
dragged the bottom of the
options?
window to extend it. So we just did the third one down from the top. And now we're on, are there any guidelines to determine baseline period, especially when it comes to manufacturing processes?
Yes, the more data you have, the better, especially for projects of this size. However, sometimes you can only get so much baseline data. It's important to cover at least a full cycle or two. We try to have, depending on the measure, we try to have more baseline data as opposed to less. Yeah, but sometimes you have to really see what you can work with and do your uncertainty analysis, which is a big part of that. See how much the uncertainty of your baseline regression model would be with the data that you have. Yeah.
Okay, the next one says, thanks for the great presentation. I would like to know if the sectors mentioned in this presentation are in descending order of energy consumption rank.
Mm-hmm. So the sectors are by energy savings. So I have the 10 largest sectors shown here. And this is the in energy savings, contracted energy savings that are under MMV, if that makes sense.
Okay. The next question you've already addressed because it was a follow-up from an earlier one. Mm-hmm. The next is there a time period for the existing on incentive program to expire?
Is there a time period?
On incentive program to expire.
Oh, okay. The interim framework carries until 2020. Projects have to go in service by 2021. Sharon, are you deleting the questions as you're going over them?
No, I'm not. I've left them in the box. So,
okay. No
the next one is one suggestion regarding the adjustment of production levels for baseline is to create KPI regarding energy consumption approximation per unit production levels. That way, any increase or decrease in production levels could be modeled and adjusted accordingly. So it's more of a comment than a question. It's a suggestion.
I see.
So then the next question is, how do you handle MMV where you have whole building metering prior to the energy conservation measure, but sub-metering only after the measure installation?
How do you... Oh, wow, I can't keep track of these questions. Did we skip over some?
No, I'm working from the top down. So I'm
okay, then I can't see these questions.
I'm looking for a question. I'm looking at a question from Justin Williams. So if you scroll up, you should see Justin.
Yeah, the first question I see is what option did you use, D or A, for CHP systems? I can't see any questions that are before that one for some reason. I can't scroll up any further.
Okay, I don't even
That's
see
fine.
that question, but
Okay.
we'll just keep going down.
Fine.
Go ahead.
Sure. Do you want to read that out to me again?
I will, yes. Sorry, everybody.
you.
We're having some technical issues. We'll work through them. Okay, so the question was, how do you handle M&V where you have whole building metering prior to the energy conservation measure, but sub-metering only after the measure installation?
Would that be whole facility sub-metering? It would be for the ECM?
I do not know on that one.
Okay, we can touch base on that after. If you want to email me, we can have a discussion on that later.
Okay,
take that
then
offline.
The next one is for the MMV of the CHP.
I'm going to go back to my, email. There we go, email address here.
The next question is for the MMV of the CHP systems, what parameters did you measure and for how long?
Sure. So MMV of CHP typically falls under option B all year because it's continuous. So it would fall under option B. What parameters? For smaller package systems, it is usually the net electrical output that's measured. For larger CHP systems, it is the gross electrical output. Auxiliary loads are sometimes estimated, sometimes metered, depending on the size of the system as well. And then on the thermal side, we have thermal metering, which would give us the utilized heat of CHP and the fuel consumption of the CHP, the gross electrical output, the utilized heat, and the fuel consumption would be used to calculate the total system efficiency of the CHP system.
Okay. Next question is the CHP incentive still available and what is required for the M&V process?
The CHP incentive is no longer available. New applications were not accepted after July 2018. Yes.
Okay, the next one was, and this is a follow-up to an earlier question, but it says, I mean, if there were many M&V contracts in food and beverage sector, does that mean that this sector has the top rank in energy consumption in Canada?
I think that would be, I'm not sure about that.
That may be one, but
I don't
the whole
think I can
question.
speak to that, but it's definitely a sector that has a very high energy consumption because of the steam that's used, high pressure, high temperature steam, hot water that's used, as well as all the electrical equipment. Yeah. So definitely on the high end, I'm not sure if it's the highest. I can't speak to that.
Okay, so then the follow-up to the M&V of the CHP system says, also, what options did you use, D or A, with CHP systems?
Option B is typically used for CHP systems because the meters are continuous.
Okay, next question. Can you mention any non-routine adjustments used?
Sure. So an example of a non-routine adjustment, I'll give you a hypothetical example. Let's say a water treatment facility is treating a specific volume of water per year. Let's say another nearby water treatment facility closes down for whatever reason, but this was not anticipated when you developed the MMV plan. When the project, let's say the project is a pumping upgrade, which is a typical one in a water treatment system. So let's say when the reporting period reaches for that specific project, all of a sudden flow rate is so much higher, there's so much more water that has to be treated, which leads to a higher energy consumption. That is a non-routine adjustment, because it is a result of a nearby plant closing down unexpectedly for whatever reason. Okay, next one.
Okay, what's your advice for a startup interested in doing M&V in the hotel industry? Tips and pitfalls to look out for. Thanks. I think that one might be a good follow-up one, perhaps for email.
Sure, yeah. Sure.
So we'll move along to the next. So we're not ignoring your question, but that might be a follow-up one.
Feel free to get in touch with me later.
Have you done any M&V for process equipment, non-weather sensitive type?
For process equipment, non-weather sensitive. Yes. I think we would need more details for that question potentially. So if you want to get in touch with me after the presentation, we can chat on that.
Okay, the next one. How do you calculate parasitic losses and how do you determine fuel offset?
Parasitic loads, I'm guessing this is the CHP parasitic loads?
It does not specify, but...
Okay, so if you want to get in touch with me as well, we can touch base on that later.
Just responded at the bottom, yes.
Okay, so auxiliary loads for CHP, for larger CHP systems, it's recommended that auxiliary loads are measured. As I mentioned, for calculating the total system efficiency, the gross electrical output is used. However, the savings are the net electrical output, and the incentive is based on the net electrical output. So it's definitely for larger systems, especially, it's definitely recommended that auxiliary loads are measured. If that doesn't answer your question fully, feel free to get in touch with me and we can discuss.
Okay, the next one is how do you set the best adjustment factor in HVAC projects?
That I think we would also need to discuss more. HVAC projects are, it's a little bit difficult because HVAC projects are usually smaller and they fit better in more prescriptive programs such as the retrofit program as opposed to the PSU program. However, we do see HVAC measures as well. Based on my experience, hours of operation is a common one for HVAC. But yeah, feel free to get in touch with me and we can have a more detailed discussion on that.
Okay, it says, how do you verify measure life? Do you use approved or assumed values?
Measure life. Measure life, we use standards that are available, such as the Wisconsin study. We can also touch base on that later.
Okay, energy use can also vary based on product mix being processed. In that situation, what strategy would be used to achieve reliable results?
Sorry, Sharon, could you repeat that one again?
Sure, energy use can also vary based on product mix being processed. In that situation, what strategy would be used to achieve reliable results?
I'm not sure how to answer this question.
I'm just trying to see if I think that might have been a follow-up to an earlier question. Yes, it is. So again, I think that's one that maybe you need to reach out individually on that one.
Sure. Yes.
And then
yes. So we're not ignoring your question. Feel free to get in touch with me later.
Then we have what would be the baseline for new construction projects?
Depends on the project. But that I think that's a really big question. Yeah, so if you want to have a discussion about that, feel free to reach out to me. But I think that's a pretty complicated question. It's very vast in scope.
Okay. How often do you assume a consumption data have a normal distribution, or do you build a specific district model for an exact project?
No. I'm not sure if I can answer this question either. Normal distribution.
It might need rewording, I'm not sure.
Yeah, okay. Yeah, feel free to get in touch with me. I'm not sure. I'm not sure if I understand this question completely.
Okay. Did the realization rates include interactive effects?
So how we deal with interactive effects is we meter them. So if we identify any interactive effects in the MMV plan during the project review stage, we would ask that the interactive effect. By metering, you basically eliminate the interactive effect because as you would subtract it from your savings. Feel free to get in touch if that doesn't make sense, but yeah, a big part of MMV is taking care of the interactive effects early on so that they're not falsely adding to your savings amount.
Okay. Have you adopted the use of MMV 2.0 techniques over standard option C?
This question would not apply to what we do a lot, just because MMV 2.0 would go more on the facility side. So maybe the energy managers or the industrial facilities would be using more of MMV 2.0. Also, as I mentioned, we don't really see option C. We rarely see option C under PSU. There's another program, EPP, that you might be familiar with that uses option C, but yeah, EPP was not part of this presentation. Feel free, if you have any EPP questions, feel free to reach out and I can direct them to the right person at Clear as well.
Okay, so I think this looks like it may be the last one for now. Do you use any specific statistical software and tests for regression?
We use Excel.
Okay, and then it says in my next...
Mostly we use Excel, but there are other softwares that are used, yeah.
And there's a continuation on that, and it says, and my next question is related to non-routine adjustment. What can the non-routine adjustment be in an official building when the area used is expanded in the reporting period?
That is the non-routine adjustment. I'm not sure what this question is asking.
Okay, and what, so whoever wrote that question, either reach out or perhaps reword that question to help. And that, I think, brings us to the end of our questions. So I just want to follow up with a couple of things here. Give me just a moment here. I'm just trying to get my screen set up and take control back here. So I'm just going to switch presenter back to me. And I want to say a huge thank you to you, Kimia. We appreciate your time and your expertise today.
No worries. Thanks for having me.
Our pleasure. And following on from your presentation, we do have some upcoming CMVP training. We have 2 more live training events happening before the end of the year. One this month, the 14th to the 16th in Dallas, Texas, and another in November from the 11th to the 13th in Anaheim, California. We also have a couple of online options for you. So please take a look at those. And if you are searching for training, I want to just give you guys a quick heads up. Here on our website, right here, under this section right here, when you first log in, or you don't even need to log in, but when you first get to here, if you go to training seminars across the top, in here you can search for any kind of training that you want. So for example, if I was looking for CMVP within the United States, I'm going to choose my CMVP in here, United States, and then I can choose live, online, or a non-certification. I'm just going to say any and hit apply, and it will break all of that down for you. So you can use this. Obviously, this I searched specifically for CMVP because it's related to today's webinar, but you can search for any of our classes in here. So please feel free to look on there, and if you need assistance with that, please feel free to. Just to make you aware of our upcoming 2020 events, we just finished with World 2019, and it was a pleasure to meet several of you there. Thank you guys very much for those of you that attended. If you did not have an opportunity to attend last year, or sorry, should I say this year, any of our events, we do have our East, West, and World events coming up next year. We have East in April in Cincinnati, we have West in June in Seattle, and World in Denver, Colorado in September, but we also are going to have our first European event, which will take place in Dublin, Ireland in October. We hope that some of you will make it out to some of these events. And our next AEE member webinar will take place in a couple of weeks, on Wednesday the 23rd, we will be hearing from Jeff Blankman, who is the Sustainable Manufacturing Manager at McCormick. Real-world industrial energy efficiency, how McCormick sustainability produces your favorite spices and seasonings. So hopefully I will see many of you again in a couple of weeks. But for the time being, thank you everybody that attended today, and thank you, Kimia, for your presentation today. Once again, we truly do appreciate your time and expertise for our AEE members.
No worries. Thanks for having me.
So with that, I will sign off. Thank you, everyone. Bye.